So 5b says, here's my first parameter is t equals x2 minus x, and x equals t here. So if the x equals t, then in place of that, I'm going to plug my, wait a minute, hang on, sorry. Find a set of to represent the graph using the parameters.
The y equals x cubed plus 9x.
This one.
Yes.
Oh, I got you. That's the question. Yep. That's right to the bottom. So y equals x to the third plus 9x is the one that doesn't have the t, and then I've got t equals 2 minus x. So I've got to solve that one for x. Subtract the 2. Divide or multiply by -1. And then take that, plug it in here. So I'm actually going to rearrange it so that the 2 is first, just because I hate having a negative at the front. 2 minus t to the third plus 9, 2 minus t. And then that expanded to the second power would be this, which is 4, double the product, minus 4t plus t squared. And then that times 2 minus t. And I'd get 8 minus 4t minus 8t plus 4t squared plus 2t squared minus t to the third. Combine the like terms here and here. So 8 minus 12t plus 6t squared minus t to the third. That's that one.
Wait, how'd you get -4t? Like multiplying the...
So it's squared, right? So square the first, square the last, double the product is the middle part.
No, that's second 4t. Because it should multiply with the negative t that's a positive.
That's 8, negative 4t, negative 8t, positive 4t squared, 2t, negative t, right?
Oh, okay.
Yeah?
Yes.
I mean, I make lots of mistakes, so feel free to catch them. Okay, and then plus 9 times 2, which is 18, minus 9t. This is what y equals. So then just combine your like terms here. They have it in order so that the constants, they have it in decreasing degree order. So negative t to the third plus 6t squared minus 12 and minus 9 minus 21t, and then positive 8 and positive 18, positive 26. And then the x equals 2 minus t from this one. So you have to have both.
Yeah, I put both.
Right. Oh, yeah, no. It's just your numbers are wrong on the second one, right? This is what you put.
Oh.
Yeah.
I'm like, oh,
That's the right answer. Yeah.
I did it.
All right, so we're going to start 9.5 today. Okay, so 9.5 is called polar coordinates. Between 9.5 and 9.6, 9.6, then we graph equations. But right now we're learning how to graph on a completely new grid, which is called a polar grid. So this kind of combines plotting points in with unit circle. So I know I said at the beginning of the school year, but like unit circle is one of the most important things that you're going to learn this year because it's going to get used so many times. And I said even at the very end of the school year, we're going to come back to it, and this is why. 9.5 and 9.6 are going to use it. So the better you are, or the more familiar you are with your unit circle, the easier something like this would be. So the polar coordinate system is formed by the fixed point being the center or the origin. We now call the pole, okay? And it's constructed from an initial ray called the polar axis. So basically, it's an angle on our unit circle, okay? But instead of only going out of a radius of 1, it's going to vary. So the polar axis is what we formally called the x-axis. It's where our 0 radians or 0 degree line is. The origin is now called the pole. And we're going to be using the angles around our unit circle. So the r may no longer just be 1. So this can be any value. Okay, on a unit circle, it's just 1. We still need thetas, so we still need to know where pi over 6 is, pi over 4, pi over 3. All those angles around your unit circle are the theta part of this, and then the r is your radius part of this, and it almost looks like, you're going to see in a second, but almost looks like a bullseye or a dartboard where there are rings in it, concentric rings in it, and each ring represents one r. So each point in the plane can be assigned what's called polar coordinates, and instead of it being x, y, it is r theta. The r is the directed distance from 0 to p, which is also known as the radius, and theta is the directed angle. It goes counterclockwise, just like we're used to, from the polar axis to the segment. So r, radius, theta, angle, and these angles will be given usually in radians. I will give them to you in radians, but like if you look up practice on the internet, sometimes they give it to you in degrees. Just know that's the same thing. All right, so the first thing we're going to do is plot these points. So it says to plot the point. I actually would recommend that you Google polar coordinate grid and save that picture. It will look something like this. I would put it right in my, if you're a nerd like me, your favorites are full of graphs. Okay, but I would put it right in your camera roll so that you can reuse it. This is a polar grid. So I would Google, again, polar coordinate plane. Find something like this. Doesn't have to be perfect. Something like this. And then save it to your camera roll because you're going to reuse it. God bless you.
Thank you.
This is not the one I will use for your answer sheet when I make, because I don't like the inner rings. When I find that one, I will post it so that you can just download that one so it's the same one. But it will be on your answer sheet. All right, so notice that this kind of, like I said, it kind of looks like a dartboard. It's got concentric circles, which are circles that have the same center. Let me group this. Okay, notice that just the pi over 4s are marked, but halfway between the pi over 4 and the 0 would be pi over 6. Halfway between pi over 4 and pi over 2 would be pi over 3. And then they would continue on in the direction around your circle. So this has too many lines in my opinion. That's why this won't be the one that we use, but just so you can get an idea of what it would look like, it'd be something like this. Each ring is one radius. So that little blue circle is what we normally operate from in our unit circle. Now we're going beyond that. So that's 1, keep going, it's 2, keep going, it's 3, and so on and so forth. So when I plot this 2 pi over 3, 2 is my r, pi over 3 is my theta. First thing I do is locate theta on my unit circle. So pi over 3 is up here. I'm going to use this line. And then I go out that many rings. So it says 2. I'm going to go from the center or the pole out 1, 2, and I plot a point. This is a coordinate point. So it's just a dot. That's an arrow. B says r is 3, theta is negative pi over 6. Remember, negative pi over 6, we go in the opposite direction. So we'd be going this direction. We go clockwise instead of counterclockwise. Or we locate the positive angle, fold our unit circle along the x-axis, which now is the polar axis. And where it overlaps is where it would go, which is this same angle, negative pi over 6. And then my coordinate point is 3. So I go to the third ring along that line. That would be 3, negative pi over 6. So obviously you can have a unit. Oh, yeah, Anthony.
Will the ring always be numbered?
Yes, but you might need to go beyond the ring. So if I gave you a ring, if I gave you something with 3 rings or 4 rings and you have to go to 10, you would just jump out. Doesn't have to be perfect. Just jump. I don't know if you guys heard that. That was a good question. Will the rings always be numbered? Yes, to start with, but you might have to extend it out beyond. Like this one doesn't have 4, but like if I went to 5, you'd still have to be able to plot it.
Like, you know how there's like rings in between them?
Like that's why I said I don't love this polar. It's the first one I grabbed, but I don't love it because you won't have the rings in between. That would be like a half. Like that would be a 2.5 or 3.5, that kind of thing. I'm going to try to find one, and if I don't find one, I'll make one that doesn't have the in-between rings on the angles and on the rings. Yeah. The other thing is, I mean, we can make it. It's the same concept. But the other thing is that, what was I going to say? Oh, because you can use your unit circle, these angles will most likely not be straight from your unit circle. So remember, you're going to have to know your coterminals, okay, or your negatives. All right, so you do A, and then we're going to do B together. Here, let me see if I can find her while you're doing that. Okay, so for 3, 11 pi over 6, again, I would go to 11 pi over 6, and I would go to the third ring, and I would plot my point, and it would look like that. So that's point A. Now, point B is a little bit different because the angle is not negative. The radius is negative. And this is super easy once you hear it, but if you don't know how to do this and you try to figure this out later, you're going to be super confused. So if I'm staring at your ceiling fan because you've gone back to bed, hopefully you can hear me say, get your butt up and listen to me, because this will be easy if I explain it to you, but you'll be very confused if you try to figure this out later. So when the radius is negative, I'm going to go to the angle that I would normally go to. So positive 11 pi over 6 is still this angle here. Now, because the radius is negative, instead of moving in the direction of that like we just did, we actually move the opposite direction. So I go from my pole opposite along that line, which puts it at 1, 2, 3, and my coordinate point goes here. Super easy. Just move the opposite direction.
Is that the coterminal angle or no?
No. So it won't be a coterminal angle, but the radius would be the opposite direction. Okay, then it says find additional points. So there's going to be questions where it's going to say, here's your coordinate, plot it, and then find 2 or 3, whatever it is, additional representations of the same point. So there's 2 ways to do this. If you're given your r theta, which is your original coordinate point, you can keep r the same. So in this example, we keep r. So we keep r the same, and then we find coterminal angles by adding and subtracting multiples of 2 pi. So I can do 2 pi, 4 pi, 6 pi, 8 pi, or I could subtract 2 pi, 4 pi, 6 pi, 8 pi, and it's going to give me the same coordinate point. That's how we find coterminals, right? The other option is that I change the sign on the r. Did it freeze? Yeah. And I add and subtract odd multiples of pi. So I'm going to move halfway around the circle because that's what an odd multiple of pi would be. And then I move in the opposite direction for the radius. So those are your 2 options. Keep r the same, add and subtract 2 pi or 4 pi or 6 pi, however many times you need to do it. Or change the sign on r and then add and subtract pi, 3 pi, 5 pi, and so on and so forth. Sometimes you're going to have to do both. And that will be like find the coordinate point that matches between 0 and 2 pi. So we can't go too big, that kind of thing. And then it says the pole is represented by 0 theta, where theta is any angle. So if I said 0 and I said pi over 2, and I said 0, and I said pi over 4, and I said 0, and I said 17 pi over 6. Those are all the same coordinate points because my radius is 0. So they would all plot at the pole. Okay, so this one says plot the point 3, negative 3 pi over 4, and find 3 additional polar representations of this point using negative 2 pi to positive 2 pi, not including those 2. So now we've got our restriction. When you give the additional ones, you need to keep it in between here. So you start by graphing that. Go ahead and graph that point. Where's negative 3 pi over 4? What's the same name for it? Positive. Can't make Clara answer all of my questions, guys. You're going to have to unmute yourselves. Remember, there's 2 ways to find it. Ella, you got the answer?
Is it then you fold it over like horizontally, so it'd be like 5 pi over 4?
Good. So negative 3 pi over 4 would be the same thing as 5 pi over 4. So negative 3 pi over 4. And then my radius is 3, right? So 1, 2, 3. Here's my coordinate point. That's the original one. Now it wants you to find 3 additional polar representations of the same point, but it wants you to keep it between negative 2 pi and positive 2 pi. So I can't subtract 2 pi from this because it becomes too small. If I subtract, so if I did negative 3 pi over 4 minus 8 pi over 4, which would be 2 pi, this is a negative 11 pi over 4, and that's too small. So I can try to add 2 pi, which becomes 8 pi over 4, and I get 5 pi over 4. That falls in between that falls in between negative 2 pi and positive 2 pi. So I can keep that one. So that's the one way is not change the r. So r stays as 3, add and subtract 2 pi, and I get 5 pi over 4, which makes sense because that's that angle. If I add 2 pi again, it's too big. So I can't continue to go that way. I have to use the other option, which is change the r. So the r becomes negative 3. Take negative 3 pi over 4, add odd multiples of pi. So add pi, which would be 4 pi over 4, and I get pi over 4. That falls between negative 2 pi and positive 2 pi, so I could keep it. If I add 2 pi again, it's going to be too big. But my other option is take that negative 3 pi over 4 and subtract an odd multiple of pi, which would be 4 pi over 4. Negative 7 pi over 4 is less than negative 2 pi, or bigger than negative 2 pi, so I also can keep that one. Change the r. Negative 7 pi over 4. So this said, plot the point, which we did over here, and then find 3 additional representations of the same point. If we actually plot each of those points, that's how you can check to make sure you're right, they should all end up in the same spot. Okay, so now we're going to learn how to convert from polar to rectangular and rectangular to polar, okay? To establish the relationship between polar and rectangular coordinates, let polar axis coincide with the positive x-axis and the pole with the origin. So we can actually overlap these grids. I could take my polar circle and I could put it on top of my xy axis, and that way you can kind of convert them. You don't have to convert them by graphing. I'm going to teach you a different way. But you should be able to plot that point in both rectangular and polar and see that they overlap. So again, remember x-axis is polar, y-axis still y-axis, but x-axis is polar, and we now call the origin the pole. So to convert, because x and y lies on the circle with a radius of r, I could actually figure it out by using my circle equation, x squared plus y squared equals r squared. And then I can work backwards to figure out what r is, or I can use these little shortcuts. So if I set up a triangle using the coordinate point as the end point of the ray, tan would be y over x, cosine would be x over r, and sine would be y over r. So we are going to use the sine and the cosine to get the x and the y, and we're going to use the tangent to get theta. So when I want to go to find x, I'm going to do x equals r cosine theta. To get the y, should make sense, right? Cosine is my x. To get the y, I'm going to do r equals sine of theta. And to get the angle, because it has to end up being an r, comma theta, right? To get the angle, I do tan of theta equals y over x. And then I'm going to do tan negative 1 of whatever I get there, y over x. So these need to be unit circle based because you don't necessarily need to use your calculator for most of these. You will see eventually we will do this with a calculator in which you don't need to have them be unit circle based. But most likely I would save that for your test and not your quiz. And if that's the case, you're only using scientific, so you won't use graphing on that one. Okay, so this says, show an answer in rectangular form. Write the answer as x, y equals number, comma, number. And when showing the answer in polar form, you're going to have to write the answer as r theta. Because if I were to do, let's say I just did 2, 0. How do you know that that is rectangular or polar? They look the same, right? 0 radians looks the same as 0 as like the y being 0. So you would have to establish that this is either r theta or you'd establish that that's xy. If it's r theta, I know it's in polar. So I would go 0 degrees, which is on my x-axis, and I would go out 2. If it was in rectangular, it'd be the same coordinate point. I'd go to the right 2, I'd plot my point. I wouldn't go up or down at all. But they all won't be the same like that, okay? So that's why we want to establish that r and theta is what we're showing that that's my polar point, and xy, that's my rectangular point. All right, so A says, convert the point 2 pi to rectangular coordinates. So you'll either see it looks like this where it says specifically 2 rectangular, so I know this starts polar, or it will say r comma theta equals 2 pi, convert it. And you'll know that you have to convert it to rectangular. So remember for rectangular, there's 2 parts, x and y. The x equals r cosine theta, and the y equals r sine theta. So I get the r from the 2, that's my radius, this is r, this is theta, and then times the cosine at pi, and then 2 times the sine at pi. I would use my unit circle, I would locate pi, I would see that the coordinate point there is -1, 0, or hopefully you know that by now. What's the cosine there?
-1.
Good, so 2 times -1 would make this -2. 2 times 0 would make this 0. So the x, y coordinate there would be 2, 0. B, convert the point √3, comma, pi over 6 to rectangular. So again, we're going from polar to rectangular. X would equal √3 is now my radius, times the cosine at pi over 6. Y, √3 is the radius, times the sine at pi over 6. So I get √3, pi over 6 is the first angle I hit after my 0, and the coordinate point there is √3 over 2 and 1/2. So the cosine there is √3 over 2, and the sine there is 1/2. Multiply these out. √3 times √3 over 2 would be 3 over 2. Multiply these out, and I get √3 over 2. So my x, y coordinate is 3 over 2 and √3 over 2. So those kind of answers you'll keep exact, just like that. So again, from polar to rectangular, it's r cosine theta, y cosine theta. Now we're going the reverse. Now we're going rectangular to polar. So for rectangular to polar, we need r and we need theta. r squared equals x squared plus y squared. We'll solve for r. And tan theta equals y over x. And then we'll use the tan negative 1 of y over x. So if this is my x and this is my y, r squared would equal 2 squared plus 2 squared. R squared would equal 4 plus 4. R squared would equal 8. R would equal square root of 8, which is 2 root 2. Then tan of theta would equal y, which is 2, over x, which is 2. Tan of theta would equal 1. And tan negative 1 equals theta. So we're trying to find where on my unit circle does tangent equal 1. Now think about this. This happens at more than one spot. Here, let me pull in. Pull in the unit circle. Okay, remember tangent is 0, root 3 over 3, 1, root 3, undefined, and that repeats around my circle. So tangent is also 0 here, negative root 3 over 3, negative 1, negative 3, and undefined. Tangent is 1 in 2 spots. Pi over 4, oh wait, this is positive. I don't know why I wrote negative, sorry. That was the whole point of it. Root 3 over 3, 1, and root 3. Tan is 1 there, and also in my third quadrant. So how do I know which one to pick? Because only one is right. Where does my original point lie? Where would 2, 2 be? First quadrant or third quadrant? First quadrant. And that's how I know which tangent to pick. So I'm going to pick the theta that's in the first quadrant, which is pi over 4. So now my coordinate point here, my r theta equals 2 root 2, comma, pi over 4. Yeah.
So, does it have to do with the fact that it's like a positive 1? Like if it was a negative 1, then would it be on the bottom, or does that not like have to do with that?
No, it does. If it was a negative 1, I'd be trying to pick between the second quadrant and the fourth quadrant.
Okay.
And then again, based on the coordinate point, so if it was a negative 1, it might be negative 2, 2, and that's second quadrant. If it was a positive 2, negative 2, then I'd pick the fourth quadrant. Good question. All right, B says convert the point negative 1, 0 to polar coordinates. So again, I'm going rectangular polar. R squared would equal negative 1 squared plus 0 squared. R squared would equal 1 plus 0. R squared would equal 1. R would equal square root of 1, which is 1. Technically, it's plus or minus 1, but radius is always positive, so we ignore the negative. Then tan of theta would equal 0 over negative 1. What's 0 divided by negative 1? Zero, good. So then I'm going to find tan negative 1 of 0. So where on my unit circle is tangent 0? I'll give you a hint. There's 2 answers.
The pi?
Good. 0 and pi, they're both 0. But because this is negative 1, I know I'm going to move left, and that means pick pi. So r theta would equal 1 pi. Questions on that one?